Okay, so here we should explain the concept of the area function and the fundamental theorems of integral calculus with examples. So, if f of x is a function, f of x is a real valued function. F of x is a real valued function, and it is a and suppose it is a continuous function also. It is also a continuous function. Then the area function for this function i- i- f of x, then the area function is given as a of x, that is equals to integral a to x f of x dx. So based on this area function, we shall explain the first fundamental theorem of integral calculus. So the fundamental first fundamental theorem of integral calculus first fundamental theorem of integral calculus um, is that if f of x is a continuous function, if f of x is a continuous function in the closed interval, f of x is a continuous function in the closed interval, closed interval a to b, and um, and if a of x is the corresponding area function of the function f of x, i- if a of x is the corresponding area function, a of x is the corresponding area function, then a dash x, that is equals to f of x for all values of x belongs to the closed interval a to b. A dash x means I can say it is the uh, derivative of f of x. It is the derivative of a of x. So that is equal to f of x for all values of x belongs to the closed interval a to b. So this is the first fundamental theorem of integral calculus. And then the second fundamental theorem of integral calculus is, so we shall state the second fundamental theorem of integral calculus. So uh, if if f of x is a continuous function, if f of x is a continuous function in the closed interval a to b, in the closed interval a to b, and if capital F of x is the antiderivative or the integral, if capital F of x is the antiderivative or the integral of the function f of x, uh, then integral a to b f of x dx, that will be equal to f of x, and that will go from a to b. So that will be equal to, sorry, so that will be equal to f of b minus f of a. So this is the second fundamental theorem of the integral calculus. So suppose we are being asked to integrate the function. For example, suppose we are being asked to integrate from 2 to 3 x square dx. So we know that the antiderivative of the function x square is x cubed by 3. So it will be x cubed by 3, and that will go from 2 to 3. and then we have to put 3 first and then 2 first, then we have to put 2 and then we have to subtract. It means we have to do 3 cube by 2 minus 3 cube by 3 minus 2 cube by 3. So that will be equal to 27 by 3 minus 8 by 3. So this will be equal to 19 by 3. So this is the answer. Thank you.